So once again, please cancel out that equal sign. Now we're going to start by finding the vertex, and we should all know that the vertex is a coordinate, and we're going to find that coordinate by using x equals negative b over 2 times a. Okay, and we're going to plug in our values into that formula, the b over 2 times, negative b over 2 times a. So the b value is negative 5, and the a value is 1. So I really have 5 over 2. So this is really ugly because we don't have a nice value for the value of x of the vertex. It's actually 2.5. You could put it as 2.5 or 2.5. I want to put it as 2.5. Now, if I have my x value of my vertex, how do I find my y value? Plug it in to the original x value. So I want to take the 2.5 and plug it in right here into this x, and take the 2.5 and plug it in into this x, and I want to simplify it all to find my y value. So the best thing to do would be to rewrite your equation, but instead of writing x's, to put parentheses right there. So we're going to plug in our x value of 2.5 and 2.5. Now, of course, we may need a calculator here. Does anybody have one? What's 2.5 squared? I believe it's 6.25, all right. So we have 6.25, and we have minus 5 times 2.5. Is that 12.5? Thank you very much. And plus 7 at the very end. So adding and subtracting from left to right, we have, it's like if you owe somebody $6.25. No, you have $6.25, but you owe somebody $12.50. You're going to owe $6.25, correct? Now we have plus 7. So if you owe somebody $6.25, you end up with an answer of 0.75, which is positive. So you take that 0.75 and put it up here as your y value of your vertex, which is 0.75. Okay, so the axis of symmetry, once again, is x equals the x value of your vertex, 2.5. And you might as well throw in vertex form. Vertex form is y equals a parentheses x minus h squared plus k. So our vertex form equation will be y equals a. What's the a value of the original? It's 1 parentheses x minus h, x minus 2.5, close parentheses squared, plus k, that's plus 0.75. So here's my vertex form. I might as well get that out of the way. And now let's actually graph the vertex 2.5 and 0.75. Let me do that. So going to the graph, 2.5, you're going to go 1, 2.5, and then 0.75 up. It's going to be 3/4 of the way up. Let's put a dot right there. So it's right here, kind of floating in between nice coordinates. So that's really ugly. That's the vertex. The axis of symmetry will be the line going right through it. So we just do a little dotted line perfectly. Well, it's not perfectly, but it's right between the 2 and the 3 at the 2.5 mark. Okay, so we need more coordinates to graph this parabola. We already know, because the a value is 1, that it opens up. We know it's going to be a U-shaped curve opening up. We even know the pattern 1, 1, 2, 4, 3, 9 because the a value is 1. However, because this coordinate is not at a nice coordinate, I mean, you could use the pattern, but I think it'll be confusing when you go from this point 1 over and then 2 up to here and you're like kind of in the middle, right? That could be confusing. So maybe instead of using the pattern on this one, you could just use an XY table. It's pretty easy to do. Let's go for an XY table right here. And what would be an easy number to plug in? 0. When you plug in 0, 0 squared minus 5 times 0, that's going to be 0 plus 7. So your output 7 for the input 0. So if you do go to the coordinate 0 on the x, 7 on the y, you end up here. And likewise, you could map that over to the other side, or you could get another point somewhere in between the 0 and the 2.5, maybe by plugging in what? What would you like to plug in to get a point somewhere in here? Let's plug in a 1. If you plug in a 1, it's going to be 1 squared, that's 1. 5 times 1, that's 5. So you have 1 minus 5, that's minus 4. And minus 4 plus 7 is 3. So the coordinate 1, 3. So if you go 1 on the x, 3 on the y, you end up right here. And now you really do have those coordinates that you could map over, thank you, to the other side. So I'm going to take this one that's 1, 2.5 units away. So you're going to go half, 1, 2. And this other one is 1.5 units, so go 1.5 units right there. So I didn't use the pattern. I actually used an XY table. And I'm drawing my parabola here. Put some arrows. You're done. So we found more coordinates. I could have used a pattern, but it's slightly more confusing because we don't have nice coordinates. What else? They ask us to rewrite in vertex form. We already did that. Is this a minimum value or a maximum value? Min value. Okay. That's absolutely right. You're up here on the y's, and then all of a sudden you reach the minimum value on the y's, and then it goes back up on the y's. So what is the minimum value? Y equals 0.75 or 0.75. That's your minimum value. What else does it ask us for? State the solutions. All right. That's usually easy. How do you find the solutions? All you got to do is find the x-intercepts, right? So all you got to do is tell me where this parabola crosses the x-axis. It doesn't cross. Okay, so in other words, it doesn't have real solutions. If this were Algebra 1 class, I would just say write no solution and you're done. But this is Algebra 2, and we know that not all solutions are going to be real solutions. Sometimes you have imaginary, which are complex numbers. Okay? So you could always fall back on the quadratic formula to find your answers, whether they're real or whether they're imaginary, or whether they're decimal values, irrational numbers. You could always fall back on the quadratic formula. So let me write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And then the best thing to do would be to do your quadratic formula with parentheses instead of those letters. So let's plug in our b value. What's our b value up on the original? Negative 5 right here and negative 5 right there. What's the a value on the original? 1 and 1. And the c value? 7. Okay. So we could do this right off the bat. A negative and a negative is a positive. So you have a positive 5 plus or minus the square root. Now the inside of the square root is what's really, really important. That's where most people make mistakes. Negative 5 squared, that's 25. Positive, because a negative 5 times a negative 5 is positive 25. And then you got to look at how many negative signs you have here. It's only 1, so it's going to remain negative. And 4 times 1 times 7 is 28. And it is all over 2. So let's continue simplifying the radicand value, the discriminant, which is 25 take away 28. That's going to be a negative 3. So you have 5 plus or minus the square root of negative 3 over 2. Now, if that were a positive 3, I would leave it like that, and that would give me 2 answers. But it's a negative 3, and whenever you have the square root of a negative, you need to take out that negative and write it as an I, an imaginary, on the outside. So I need to continue and go 5 plus minus I square root of 3 over 2. Now, I know that complex numbers always have to be separate into 2 parts, a binomial. The first part is the real part, the second part's the imaginary part. So what I'm going to do is take this denominator and split it into each one of them. So it's really going to be 5 over 2 plus or minus the square root of 3 over 2. And you're probably thinking, what about the I? The I, instead of leaving it out here in front of the square root of 3, I want to move it to the back of the whole fraction and make it I out here. So this is my final complex answers. So those are the solutions of this parabola. They're not real. You can't visually see them. The only way you could find them is by using the quadratic formula and being able to simplify it correctly. For the final thing, we need to discuss domain and range and it's good to use a visual right here, the domain is simply all of your x values. The domain are your x values. And if we think about this, this parabola, even though it goes up, it never goes straight up. It always continues to go this way forever to the left. And it does go forever to the right. Or even you can even think of it algebraically. Algebraically, when I say, could you input the number 1 right here on the x's? Yes. Could you input the number 5? Yes. Could you input 10, 20, 1,000? Yes. So the inputs, the x values, you could plug in anything you want. So the domain is x equals all real numbers because you could plug in anything you want. So what we're going to say is domain is x equals, and you're going to use the all real numbers symbol. Now the range is a different story. The range is your y values, and your y is really the up and down values. So right here we have a y value of 7. Right here we have a y value of 3. Right here we have a y value of 0.75. Then we have a y value of 3 and then 7. And then we have higher y values and higher y values. So where is this whole parabola at in terms of y? Well, we know that this is the lowest point. So what does that mean in terms of y? That your y values have to be what? Greater than or equal to what? Greater than or equal to 0.75. Perfect. That's your range and your domain.